Hello viewers, welcome again to our advanced problem series on physics for IIT JEE. So here we have come up with a new problem from the book Pathfinder. This is on the chapter motion of charges in magnetic field. So here look at the statement of the problem. In a region of space, a uniform magnetic field minus b k cap is established. A particle moving with a velocity v experiences a drag force minus kv. Obviously always drag forces are proportional to the velocity and obviously opposite to the direction of the velocity as well. We have seen in viscous drag forces. Obviously a particle of mass m and charge q is projected with velocity u I cap in this region. Find the displacement of the charge when it practically stops. So to solve this problem we will apply Newton's law on the charged particle, and that's it. So let us draw the y axis and the x axis like this, and the particle is projected with a velocity there u I cap. So that is u times I cap, and let's say for after moving, so there is a magnetic field B which goes into the plane of this paper. So as it is minus k times minus b times k cap rather, so it is along negative direction of x axis, so it will be a cross here as per this diagram. So this there will be force, say from beginning of its motion, say there will be force. So the particle will take a curved path. This particle will take a curved path. So more or less like this curved path, and suppose the velocity vector of this particle is v. So and you also have a drag force or viscous force which is minus k times v. Okay. So now let us write Newton's law for this charged particle. So what will be Newton's law for this charged particle? Simple as that, m dv dt, that is mass times acceleration of the charged particle, is equal to q v cross b minus kv. That's all about the forces, right? That is all about Newton's law applied on the charged particle. Now you have to find out displacement. Now you can see that if you integrate this expression, then integral v dt will be displacement, right? And so integral dv from the limits will be from u I cap to 0, because at last this charged particle will stop. So we get somewhat a clue to solve this problem, but there you have this v cross b, right? So velocity vector has its x and y components both. So now what we'll do for this v cross b, what we can do is that, or for all these components what we can do is that we can break up into x and y components. So this is m dvx dt times I cap plus again m dvy dt times j cap is equal to q. Now let's split this v, vxi plus vyj cross minus b times k cap. Now minus k times v again is vx I cap plus vy j cap, right? Now so I cross k cap is what? I cross k is minus j, and you have a minus sign, so I will write this expression again, dvx dt times I cap plus m dvy dt times j cap is equal to, now q vxb. So there you have I cross k which is minus j, and you have a minus sign, so that will be j cap. So qb vx times j cap. Now Next term you have what you have, q vy j cross k cap. J cross k cap is actually I, so again minus sign, so there will be minus I, so minus q b vy times j cap. Is it j cross k, sorry, I cap, I missed it. Yeah, that's what you have. J cross k is I, and so this is minus I, minus sign already I have given here. So then again minus k vx I cap minus k vy times j cap. See, now we will just separate the x and the y components and write two separate equations, one for the x axis and one for the y axis. That means one for all the terms multiplied by this I cap and one for the terms multiplied by j cap. That's it. Now see, let us separate the I cap terms, m dvx dt. So let's underline this, mark this, that's the I cap. There you have, that's the I cap term, and that's also the I cap term. So m dvx dt is equal to minus qb vy minus k times vx. Okay, now let's make this equation 1, and let us make one more equation, those terms multiplied by j cap. So m dvy dt is equal to qb vx minus k times vy. Let's make it equation 2. Now let's integrate this equation 1. So that means we can write m dvx is equal to minus qb vy dt minus k vx dt. Same thing for that. Now we can put the limits. So vx varies from u to 0, vx varies from u to 0, and this integral vy dt is nothing but the y coordinate, I mean the final y coordinate where this particle will stop. Suppose the particle stops somewhere there. Okay, so that's the x and y coordinates final. Now the displacement vector, we have to find out the displacement. So the final displacement will be square root x square plus y square. So that's our so therefore integral vx dt is x. Now same way you can integrate. Now let's, okay, so let's write from 1 what we get from equation 1. After integrating you get mu minus sign, I am multiplying both sides by minus 1. So mu equal to qb times y plus k times x. Okay, so that's let's name this equation 3. Okay, now let's do something with this equation 2. So here you have m dvy is equal to qb vx dt minus k vy dt, then let us integrate. So integral vx dt will be x and integral vy dt will be y. So and if you integrate vy, okay, so the limit will be from 0 to 0. Finally it's going to stop, and at start also velocity does not have any y component rather. So it starts from 0 and also ends up at 0. So from equation 2, after integrating, what we get is 0 equal to qbx minus, so you get, actually I can write it like this, qbx is equal to ky, qbx is equal to ky. So let's name this equation 4. Okay, now what we can do, is what we can do is now we have, so from these two equations we can find out x and y, so that problem is done. All only just the calculation part is left. So first we have, suppose we want to find out the x coordinate first and later on the y coordinate. So from equation 4 you can write y equal to qbx by k and substitute it in equation 3. So what you get is mu is equal to qby, so it will be q square b square x by k plus, already you have a kx here. So therefore you have x is equal to mu times k divided by q square b square plus k square. So that's the x coordinate, that is the final x coordinate. Now to find the final y coordinate, just substitute in that equation. What you get is qb by k. So mu times qb divided by q square b square plus k square. So that's the final x and the y coordinate, and the final displacement is square root of root over x square plus y square. And if you want to express the displacement as a vector, so that's actually this x times I cap plus y times j cap